Hello and welcome to this instructional video on FracTool, a plugin built for Abacus CAE to calculate the energy dissipated and failure force of a fracture plane through a composite aircraft component. So initially, all we want to be doing is going into GitHub at the link in the description and downloading the complete code required by going to clone or download in the link, downloading the zip, which take a little while to download. And then once that's downloaded, go into your download folder and extract it. And then we need to place the file in the Abacus plugins directory within the program on your hard drive. So just going to copy, go to that plugin file, as you can see there, and then just paste it in. Once we've got that pasted in, we can then open Abacus CAE from the start area and pick a model. I've just chosen a most recent model. This model is a complex propeller, and we can see we've got models, parts, and within the parts we've just got a single part, which is the propeller blade. Most importantly, we have a composite layup which is required for FracTool, and this composite layup is defined throughout the whole of the propeller. So we can open that up, and you can see that we have multiple plies which have a stacking direction in the Y direction and have a coordinate system defined by the datum of the propeller. Then we have each of these regions, which is where the composite is defined. We make sure that for every ply the same region is selected. Then we have our relative thickness, which should all add up. They should all add up to 1. Otherwise there will be errors created in the plugin. So next we have the mesh of the model, which is a requirement for FracTool to run. We can see here that initially we've got a mesh with an approximate global element size of 1.25, which is highly accurate but not necessary for this instructional video. So we're going to change that to 8 and create a new mesh. So in Abacus, we can select any of hex dominated, tet or wedge elements, but currently only FracTool is compatible with hexahedral and tetrahedral elements. And then finally, you can choose linear or quadratic versions of each of those elements, and FracTool is compatible with both of those. So next, we want to be opening up FracTool. So we go to the plugins, and we go to the icon FracTool. And the first tab you can see here just details instructions on how to use the plugin itself. And then the second tab is one where you can choose the model and part. In this case, we only have a single model and a single part, so there's only one choice. And then you can choose your model geometry, so we can choose meters or millimeters, an engineering tolerance, and then finally we have the place where your results file is automatically saved to. So the default for that is the plugin folder, but you can change that to whatever directory you wish. So we have the third tab, which is the material selection tab. So we have a wide variety of materials available from the material database within FracTool. And you can see the material properties in those tabs selected. Alternatively, we can click the radio button for custom material and introduce our own material properties. Although for this particular instance, we'll be using IM7. So we have 3 tabs from which you can now select the different type of cut planes we introduce. Each one of these defines something different, and for the FracTool to run, we must only have one of these selected. The first one being this single cut plane. So if we want to select this one, we click the checkbox at the top, and then we can either define 3 points defining the cut plane, either in the viewport, as you can see here, or alternatively, we can define them manually by entering the coordinates ourselves as numbers. The second tab here allows us to introduce multiple cut planes along a defined axis. So in order to use that, we have to check the tick box at the top. And then we either have the choice for a global axis, we can choose X, Y, or Z, and we click the radio box for that. Or alternatively, we can define a custom axis, and we then define 2 points, either in the viewport or manually, that describe the axis. And then finally, we can define the number of cut planes we want along that axis. So the final tab allows us to define multiple cut planes using 3 points with their coordinates of each point defined from a CSV file. It should take the form seen in this tab, and we must also remember to check the text box, and we can choose the CSV file from this file directory here. So in this particular instance, we're going to choose the penultimate tab, and we're going to define some cut planes along the global x-axis. We're going to choose 15 cut planes. Then we just make sure that you've got your material selected and your part, and then click OK. And we'll run that. And it now produces an energy versus x coordinate graph, as you can see here. Of course, the results are also exported to a CSV file. You can see the critical failure force and critical failure energy of all the planes run. And then we can scroll through the dialog box and see the failure force and energy dissipated for each of the planes that we have run the simulation for. And then finally, you can see the cut planes you've defined on the model afterwards in the viewport. You can change a different angle of view to just see those more clearly. Now we can go and view the results file generated. So the first column is the x-coordinate of each of the fracture planes defined. The next is the cut plane area of each of the fracture planes. The next, the failure energy of each of the fracture planes. Next, the failure force of each of the fracture planes. And then the last two are the critical failure energy and failure force for all the fracture planes.